All right, question 1. This is a very straightforward arithmetic sequence question. They simply tells you that u2 is 5 and u3 is 11, meaning the second term is 5 and the third term is 11. So that means you have a sequence. The first term is unknown, and then the second term is 5, and then the next one is 11, and then of course the next one is something else, right? And then it goes on and on. So part A, they ask for the common difference. Very straightforward, right? So from here to here is plus 6, right? So the common difference is simply 11 minus 5 equals to 6. Then you're done. Part B, find the first term. Well, then it's very straightforward, right? That means this also have to plus 6 to 5. It means that you will do 5 minus 6 equals to minus 1. Part C, find the sum of the first 20 terms. Then you will do the S20. This is probably given in the formula book. I actually do not know, but you should have this in your head anyway, right? So the sum of the first n term in an arithmetic sequence is n times 2a plus n minus 1d, and then close the bracket, the whole thing over 2. Another way, by the way, to remember this sum is actually the first term plus the last term times the number of terms divided by 2. So sometimes this one will come in a bit more handy than the other one, but of course in this case I think the first one is the easiest. So n is 20 since we are adding the first 20 terms, and a is minus 1, so 2a is minus 2, plus again, well, 20 minus 1 is 19, multiplied by the common difference, which is 6 over 2. And since this is a non-calculated test, the way to think about these, all right? So first thing first, you would have to cancel out 20 and 2, which leave that as only like a 10, and bracket minus 2 plus. Now what is 19 times 6, right? 19 is basically 20, right? Sort of 20. So you can treat that as 20 times 6, except you have to then minus 6. So which would give you 120 minus 6, which is 114. Now, if this is a calculated test, right, then I just plug everything into the calculator, then we are done. But since this is not a calculated test, this kind of arithmetic tricks comes in very handy. So that's 114, and 114 minus 2, 112, and times 10 you add a 0. So 112, then we are done. All right, second question. This is a Venn diagram question, so we'll see. So in a class of 30 students, okay, meaning the whole thing is 30. That means out of here, you have to write 30 first, okay? 18 are fluent in Spanish, 10 is fluent in French, and 5 is not fluent in either of these languages. That means 5 is here, okay? The Venn diagram show blah, blah, blah. Right, so here's the thing, right? A lot of students would just go ahead and write 18 here because they know 18 is fluent in Spanish. But that might not be the best practice unless you're consistent with it. I mean, unless you understand what you're writing. Because 18 actually would represent the whole circle here instead of like, you know, that part. If you write 18 here and then let's say you write 7 somewhere here, right? Then that's different because then 25 would be the whole circle. When they mean 18, they mean the whole circle. So what I would write instead, I would, on the circle here, I write 18 here. That would represent the whole circle. I mean, if you really want, you can even use a color, I mean, a pen in your case, to circle the whole circle like that. So you can be very sure that that's 18. And of course, 10 is fluent in French. So we're going to do the same thing for French, right? Let me use red. That whole red circle, okay, would therefore be 10. Right? Then it's a lot more clear into like what do you I mean by 10, right? 10 I mean the whole circle, not just the part here. Okay, so then for part A, they ask you to write down the value of Q. Wait, I think we just did it, so that's straightforward. Q equals to 5 because that's what it is. Part B, find the value of n. So you need to find the intercept. Now, you can either use, you know, your logic to think about it, because the logic to think about it is just add up all of them, right? If you do 18, if you think about it, if you do 18 plus 10 plus 5, this number would be surely bigger than 30, because that would be 33. And the extra 3 people, because you know there's only 30 people here, right? The extra 3 people must have been the overlap, because or else we would have more people than we have in the whole class, right? Because 18 is the full circle, 10 is the full circle. The middle part, let me use the green here. The middle part n here, this is a double counted, right? Double counted. So if you do 18 plus 10 plus 5, it equals to 33. That means surely the 3 is the double counted one. Therefore, we know that's 3. So you can do it like this. Then you have to write the step, right, of 18 plus 10 plus 5 minus 30, which would give you all of the double counted people, which is 3. But if you want to be really more rigorous and then to figure out, using like set notation and this and that, right, you can do something like this. Imagine what you could do is think about the union of the space, right? So S, the Spanish, union French, okay, that would be 30 minus 5, which is 25. That means there are 25 people in that thing. S union F is really this thing, okay, like that thing. That looks like a peanut. And then you also know SUF very rigorously. You actually know a formula to that, right? There's actually S plus F minus S intersect F, which is 25 here. And then S is 18, so 18 plus 10 minus S intersect F is 25. A little bit of math, you also get S intersect F being just 3. And that's just n equals to 3. So that would also work, but of course the way to think about using just logic would be a bit easier. It depends what you think about it. But part C, okay, part C. Write down the value of m and p. Well, then that's very straightforward, isn't it? Once you know that n is 3, then you can write m would therefore equal to 18 minus 3, because n is 3, right? Which will give you 15. And of course, p is 10 minus 3, which gives you 7. And if you were to write it, then you can finally safely to write 15 here. So then it's quite obvious there's a 15 means this part, right? And of course, the 7 here, which is this part. But we already done with the question, so we don't have to do that. Okay, so question 3. Part A, you were given a function of gx equals to x squared plus bx plus 11. And then they tell you that the points minus 1 and 8 lies on the graph of g. I think that's very straightforward, right? That really just tells you that if you do g of minus 1, that equals to 8. And that's really it, right? Yeah, but then this is something that you have to know, right? For any graph, for any general graph, let it be a straight line, a quadratic, a cubic, or sine, cosine, it doesn't matter. For any graph, you have to know if a point lies on the graph, if the point lies on the line, that means the coordinates of the point will satisfy the equation of that line, right? Yeah, that is generally true. That means you can simply substitute the x coordinate and the y coordinate into the equation. It will always work. It will always satisfy it as long as the point is on the line. Then therefore, what we can do is straightforward. So that's minus 1 squared plus b times minus 1 plus 11 equals to 8. And then afterwards, just straightforward. That's 1, so that's minus b plus 12 equals to 8, which will give you b equals to 4, right? That's very straightforward. Now that we know b is 4, for part B, I think we can straight away first write down the fact that gx now is x squared plus 4x plus 11, right? Okay, now let's read part B. So they say the graph of just x squared is transformed to obtain the graph of g. Right, then we know we're dealing with a transformation. Let me first sketch the graph and see what it looks like. All right, so normally, let me just write this. Normally your x squared graph looks something like this, right? That's your y equals to x squared, right? And then that's x, that's y. And then they go ahead and give you like a g, right? I mean, from the looks of it, I don't know what it looks like for now. Let's just assume that g looks something like this, right? Let's say g is like that, yeah? And that's 11, because we know that's the y-intercept, right? I mean, like, this is just made up. G might not look like this. I'm just, showing it what does the question mean, right? And they're asking you, okay, now if G is the red line, what transformation has it gone through? Now, when they say transformation, they mean the translation, the stretches, and all of those, right? So, yeah. Now, the way to do this, actually, the first thing you have to do is actually to complete the square of the function of the quadratic. It might not be obvious why, but once we've done it, it'll be quite obvious why we do that. Right. So to complete the square, I hope by now you should have known how to complete the square. But the way to do it, okay, look, you do x squared plus 4x, and then you take the 4 here, you take the middle term, the coefficient of the x, the plus 4, divide by 2, and then square it. So 4 divided by 2 is 2, and 2 square it is 4. So you do a plus 4 straight away, and then you take away 4 straight away, and then you keep the plus 11. Right? The reason why we do this is, let's first consider, let me just write it here. If I ask you to do something like this, right? If I ask you to do x plus 2 squared, that you would get x squared plus 4x plus 4, right? And therefore, if we do the forcing the plus 4 here, what we can get is that this thing, like right here, actually goes straight into a perfect squared. X plus 2 squared, and then the minus 4 and plus 11 give you a minus 7 afterwards. Right, and the reason why we know that's a 4 that we need to force into the quadratic. Now this plus 4 is the one that we force, right? And the minus 4 here is just so that you can't add a function by 4 out of nowhere, right? If you add 4, you just got to subtract by 4 afterwards to sort of compensate for the fact that you added a 4, right? So then the reason why I know that's a 4 is actually what I did is, if you think about this, right? X plus a squared in any general a, right? That would go into x squared plus 2ax plus a squared. That means if we just compare the thing, right? Let me use a different color. If we just compare, let me use a nice yellow. If you just compare the coefficient of the x, that 4 must have been the 2a, right? Therefore, I first divide by 2 to get what my a is, and then I square it because the a squared is a constant that I have to force into the quadratic to make a perfect square. So that's why I divided by 2 and then square it, right? So once you got that, sure. I hope that would be obvious on why we complete the square, because now that we know gx is that, okay, let me just write it on here. The original function was that fx equals to x squared, and now it transformed into the gx of x plus 2 squared and plus 7. Yeah, I hope by now you see why we complete the square, because from here it's very obvious what kind of transformation have this gone through. But for function transformation, yeah, I don't know. I mean, I don't know. By now you should know, because this is something you learned a few years ago. But let me just briefly go over how to think about function transformation. The quick way to think about it is to ask yourself 2 questions. The first question, is it inside or outside the function, right? Inside or outside, right? Now, what do I mean by that? I mean, the original function was x squared, right? That means the plus 2 here is inside the function, because the original function was x squared and the plus 2 happens inside the square, right? So it's inside the function. Same with your sine and cosine, actually. Now, yeah, so if it's inside, okay, if it's inside, it will be a horizontal transformation. Horizontal. If it's outside of the function, it's a vertical. Okay, it's a vertical. Right. Then afterwards, that means actually the plus 7. Let me use blue. That means this plus 7 is outside, right? Because the 7 happens after you square it, right? So yeah. And afterwards, you just got to ask yourself another question: is it plus or minus, or is it times or divide? If it's plus or minus, it will be a translation, meaning simply just moving the graph. If it's times or divide, it would be a stretch. S-T-R-E-T-C-H. Yeah, stretch. All right. Then you look at this, right? Both of them are plus, right? That means both of them are a translation. That means the plus 2 would be horizontal translation, and the plus 7 would be a vertical translation. Now, there's one more thing, which is actually quite important. The third thing here, let me spread as well. The third thing here is that, remember, all horizontal transformation works the opposite way you think it does. Opposite way. Yeah, opposite way you think it does, all right? Meaning, okay, a +7, let's say this +7, right? Is a vertical translation. If it's +7, surely it just goes up by 7 unit, right, basically. However, for the horizontal, if it's +2, surely you might be thinking that means it moved to the right by 2, right? But the fact that no, all horizontal transformation works the opposite way you think it does. If it's +2, actually you have to move to the left by 2. All right, so this is actually moving to the left by 2 units. Okay, so yeah, I'm not going to write down the full answer. The full answer you have to write is that the transformation is that the graph first move to the left, translate horizontally to the left by 2 units, and then translate upward by 7 units vertically, right? So that would be it, right? Yeah, the more proper treatment of transformation, of course, is not to memorize or understand this kind of stuff, but this is a very quick way you can spot the transformation, and this works for every function transformation as well. Yeah, and also the idea that all horizontal transformation work the opposite way also work for stretching as well. Meaning, if you have a function, let's say, let me just put it here. Imagine if you have a function fx, now it goes to f times 5x, like that. Now, of course, it's inside the function, right? So it's got to be horizontal, it's multiplied, so it's a stretch. So you'll be thinking, oh wait, so if we multiply by 5, surely it's stretch bigger by 5, stretch the whole line wider by 5. But no, remember horizontal, so it actually squeezes the line 5 times, right? You call this a horizontal compression of a scale factor with a scale factor of 5, right? All right, question 4. So it's a very typical binomial expansion problem. They even gave you like the sort of like formula for the NCR, right? So consider blah blah blah. That notation, by the way, is actually the same thing as 11CA. Okay, so some people write it like NCR, some people write NCR, and of course some people for some reason would do something like that, which I think is the worst way. Because that looks like a vector, doesn't it? I mean, even though it's quite obvious you're not doing vectors, but doesn't that look exactly like a vector? So I don't know why they don't do NCR like this or that. Anyway, so you should know, right? The idea of NCR, okay, I'm going to use my notation, but it's the same, right? It's actually just n factorial over r factorial and then n minus r factorial, okay? And then, so 11 CA is just 11 factorial over r factorial is a factorial and 11 minus a factorial, okay? And the fact that that equals to 11 factorial over a factorial and 9 factorial, I think that's quite straightforward. You don't have to go ahead and probably solve it. You can do something like, like when you are very small, you play those games where you were given like 2 pictures, like picture 1, and then you have picture 2, and then like you have a bunch of objects here, you got to find a difference between them, right? Like, okay, find 5 differences between the 2 pictures, and then you circle them. In a way, we're doing the same thing here, right? You look at the 2 expression here, 11 factorial, 11 factorial, a factorial, a factorial. If these 2 are equal, surely that means this has to be 9 factorial, isn't it, right? That means you can simply do 11 minus a factorial equals to 9 factorial. And of course, same thing, if that means a is 2, okay? Like that's very straightforward, all right? So a is 2. Now part B. Hence or otherwise, find the coefficient of the term in x to the power of 9 in the expansion of blah, blah, blah. So the binomial expansion is given like this, right? If you have simply a plus b to the power of n, that would just be the summation. The reason why it's a summation, we'll come to that later, from r equals to 0 all the way to n of NCR, and then a to the power of r and b to the power of n minus r, right? So what that really means, let me just write it out and it'll be a bit more easier to understand. Is the first term. The reason why it's a summation is because like the expansion includes like a lot of terms, right? That's why you're going to keep adding each of the terms. Meaning the first term would therefore start with R0. So NC0, okay? And then A to the power of 0, and B to the power of n minus 0 is n, right? And then the next term is going to be NC1, A to the power of 1, and B to the power of n minus 1. And you can see your normal, thing that you expect, right? The power of A start increasing, and then the power of n start decreasing, and then you have the coefficient in front, right? That actually is like your Pascal triangle, right? So that's how you do, and then of course plus dot 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 all the way to the end, right? And then the end, the final term would therefore, it would be n, c, n, A to the power of n, and finally B to the power of 0, right? So that would be, the end of the thing. Now, in that case, they only ask for one term, right? That means you are looking at like just one of these terms, right? So what you can do is simply pick out what you need, right? You need the term with the x power of 9, right? So you'll be looking into 11, since the power is 11, right? N is 11. So 11 C9, because you're looking at the x to the power of 9, right? And then x to the power of 9, and B, in that case, B is 3, right? So 3 to the power of 11 minus 9, which is 2, right? That would be the term of x to the power of 9, right? And then if I write it a bit nicer, you get 11C9, okay, multiplied by 9, of course, and then x to the power of 9. They ask for the coefficient, right? Now, please be very careful. Not like this part, this is the coefficient. It does not include the x to the power of 9. The whole thing is called a term, right? The whole thing here, this whole thing is the x to the power of 9 term, okay? And that is the coefficient, all right? So if they ask for the coefficient, please do not include your x, right? Okay, then let me just continue here. So that means 11C9. You'll be doing 11C9 times 9. So I can, times 9. Then 11C9, which would give you 11 factorial over 2 factorial times 9 factorial, and then multiply by 9, of course. And then, just so you know, the 11 factorial and 9 factorial could cancel. The reason why is, let me just put in this corner right here, right? 11 factorial is like 11 times 10 times 9 times blah, 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 right? And over, if it's 9 factorial, it's 9 times 8 times blah, 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 blah. So that whole thing actually cancels out with the 9 here. So that's just 11 times 10, right? So therefore, this is just going to be 11 times 10 over 2 times 9, which is quite straightforward already. The answer would therefore be 495, and then we are done. But please remember the coefficient is the number. It does not include the x to the power of 9. If you put your answer as 495, if you put your answer as 495 x squared, that is wrong, okay? That is not the coefficient, that is the term, okay? All right, question 5. Consider the function f with the derivative f dash or f prime x equals to 2x squared, blah, 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 with a bunch of k's, right? So they ask you to show the discriminant is k squared minus 16. So when you do discriminant, you already know you're going to deal with b squared minus 4ac, right? So I don't know why there's a line, but yeah, so you always have to do b squared minus 4ac, and therefore when I do my discriminant, I would always make sure I know which is my a, which is my b, which is my c, right? And in this case, it's actually quite straightforward. B is just 5k, right? And 5k squared minus 4ac. A is 2, and c is 3k squared plus 2, right? Yeah, equal. And equal, that's 25k squared minus 24k squared. That's 8 times 3, right? And 8 times 2 is 16, so minus 16, which would therefore give me, I'm going to save some space, I'll write it here, k squared minus 16, and then you're done. Right, part B, however, interesting. Given that f is an increasing function, Find all possible value of k. Like, other of you might be wondering, wait, what's going on? Like, how do I do it? So you have to really think about what does it mean by the fact that f is an increasing function. That is that's the clue that is given to you, right? What does that really mean? Let me first write, if you have a function, surely I write a coordinate, right? Right, a function that only increases. The most straightforward function that you can think of is, for example, y equals to x, right? Because this only increases, right? But this time you have a cubic, right? If you differentiate and get a quadratic, that means the f is a cubic. But it doesn't really matter. Like, you have a function that only increases, okay? A more rigorous way, a more technical way of saying this is a monotonically increasing function, meaning a function that only increases. It could look something like this. It could be a function that just, boom, straight off increases, right? So how has that to do with, the derivative? Now, here's the thing. You have to know what does it mean by derivative. Derivative, if you differentiate a function, the derivative actually gives you a function that allows you to find the gradient of the function at any given point, right? Let me draw it a bit nicer. Let's assume, the function looks something like that. Fine. Now, this is a very typical x cube graph, a cubic function graph, and also it's keep on increasing, right? So let's call that f. So what that means when you differentiate it is that you differentiate it, and then if you put the value of x, you could find the slope of any given point. The tangent line. If you draw a tangent line, that's how you find the slope anyway, right? So you can find the slope of all of these points, right? All of these points. And if you think about it, if the function always increases, that means the slope could only be positive, right? Because if you have a declining slope, in contrast, right? If I have another function that, is not only increasing, at some time you have downturns, right? It goes down. Then at some point here, the gradient, the slope would be negative, right? Like this would be negative slopes, right? And if the function only increases, the slope would ever only be positive. Now, here's the thing. The wording in this question is not that nice because they say increasing function. They didn't say whether it's actually monotonically increasing or like strictly just increasing, right? Because that means maybe it could also, just not increase, right? So what I mean by that is like this is a function that only goes up, but you can also have a function that do something like this. At some point, it also flats out a little bit, but it's not decreasing. So that means actually there would be two ways to write this. That means you can either do f prime, right, the derivative of x bigger than 0, or you can actually write f prime of x bigger than or equal to 0. Which, if it's strictly bigger than 0, that means the function only increases. It doesn't even stop. It just go like shoot up, right? For example, something like an exponential function would behave exactly like this. However, like it could also be, at some point it flats out a little bit. But it's not decreasing. So either way is okay. I would assume that the mark scheme would say either way is fine. Let's just do, let's just do the first one. Let's just do the first one. It doesn't really matter. If anything, in your exam, if you're not sure, you can justify it, right? Because they say it's an increasing function. You don't know which is which. Both of them are increasing, actually, right? All right, now, okay, here. So let's use the first one, okay? It doesn't really matter. So f prime x, now that you know that, you can write this like this, right? So you would have 2x squared plus 5kx plus 3k squared plus 2 has to be bigger than 0. Now, you can go ahead and really try to solve it, but the idea that this is bigger than 0, now that's a quadratic, isn't it? Like if the f dash is a quadratic, right? So let me just on here also draw the graph of that, right? So if I do this, it's a quadratic. Actually, I don't even need the y-axis, to be honest, because I just want to show the fact that it's a quadratic, right? So so imagine if this is a quadratic f dash x. I need it to be bigger than 0, meaning it couldn't have touched the x-axis, right? If that is your f dash x, right? If that is your derivative, if that's your quadratic, if it has to be bigger than 0, that means it couldn't touch 0. It couldn't cross 0, couldn't touch 0. That actually means that the discriminant is smaller than 0. Okay? The reason why is, remember when you learn your quadratic, any touching points, any intersection of the quadratic with the x-axis is the solution, right? If I have another quadratic like this, right, then these 2 points would be the roots, right? And since it crosses as 2 points, you would have b squared minus 4ac bigger than 0, right? And of course, if it touches at 1 point, then it would be equal 0. But in this case, you want the quadratic, that is the quadratic here, right? You want the quadratic to be bigger than 0, meaning at any single point it couldn't touch the x-axis. Because if it touches, it won't be bigger than 0. In that case, there couldn't have any solution, meaning the discriminant have to be negative, right? And very luckily, we actually find the discriminant above, which is k squared minus 16, has to be smaller than 0 then. The argument that you can make here is the fact that since the quadratic, since f prime x does not touch the x-axis, right? Or a better word is intersect, but that's fine. Like, that's the argument that you make, right? Therefore, the discriminant is smaller than 0, and the rest is quite easy. Then you just got to solve this quadratic inequalities. Now, the way to solve quadratic inequalities is to sketch it. All right, it's to sketch the graph. Now you get k squared minus 16 is that, right? So the quadratic of k squared minus 16 looks something like this, right? That's that, right? And then of course that would be k, right? And then this and this would be 4 and minus 4. Right? That would be k squared minus 16, right? The way to solve quadratic inequalities, the way that's easiest and you do not make any mistake is to do this. I mean, of course, you can actually solve it mathematically, but you'll be running into like you have to be really careful about your signs, your positive and negative signs. The way I do it is I visualize it, right? If there's k squared minus 16, and because like okay, these 2 points, right, is the minus 4 and 4, right? Now what you're looking for is that you want the part such that k squared minus 16 is smaller than 0. So you're looking at that part. You're looking at that part, right? And if you're looking at that part, you're looking at the region between 4 and minus 4, right? Therefore, your solution is that k has to therefore be between 4 and minus 4. Exclusive does not include 4 and minus 4 because we are not using the equal. We are not using this one here, right? So we will keep the exclusive. So that will be it, right? And this is the way how you solve quadratic inequalities. I'm not going to go over too much about it here because you should know this by now. The way to do it mathematically is also okay. What I mean by that is you can do k squared minus 16 smaller than 0, and k squared has to be smaller than 16. And you think about it, right? If k squared have to be smaller than 16, it means that k has to be, between 4 and negative 4. I mean, that's the only way you can think about it. There's no way around it. That means k has to be between 4 and minus 4 because the way you just do is just check the numbers, right? If k is like really big, if k is 5, then there will be 25, which doesn't work. If k is negative 5, it also gives you 25, which also doesn't work. So you have to be between the 4 and minus 4. But the way I do it, I visualize it using the nice quadratic, which is also nice. You can see it. Also, it applies to other quadratic as well. All right, question 6. Let the function x equal to 4 cosine x over 2 plus 1, and then of course you have the range. Find the value of x for which fx is below that value. You can either do it graphically, but I mean, since you don't actually have your calculator, you probably shouldn't do it graphically, right? So the way you do it is you actually do it, right? You just write it down. So 4 cos x over 2 plus 1 have to be bigger than 2 root 2 plus 1. Then you can tidy this up, right? So you can tidy, or you can take away a 1 on both sides and divide 4. So you get cos of x over 2 has to be bigger than root 2 over 2. Now, since this is a non-calculated test, it would always be like this. The angles will always be so nice, okay? As in, like, you can always do like root 2 over 2, root 3 over 2, because or else you wouldn't be able to do sine and cosine by hand, right? It has to be those nice angles. Just so you know, root 2 over 2 is actually 45 degree, meaning cosine of, well, 45 degree, which is pi by 4, okay? Pi is 180, right? would be root 2 over 2. This is something you have to know. That special like table thing you have to memorize, okay? Then the next thing is you can't go ahead and really just try to solve it because it's an inequality. Whenever you're dealing with an inequality, you have to be very, very careful, right? You have to really look at the region and look at the graph. So what we're going to do now is we're going to finally sketch the function, right? So we will sketch cosine of x over 2. Okay, so I'm going to have the nice cosine graph here. So that's y and that's x. For any one of you who are wondering how to sketch this, all right, you have to at least know how to sketch a cosine. Okay, now that's no way around it. A cosine is something that looks like this, right? A cosine start at 1 and then do this. And a period of cosine is 2 pi. Okay? Now here's the thing. You're doing cosine of x over 2 instead, which means it's a function transformation. Now if it's a function transformation, again, you have to know how to do it. It's a divide to. The divide to is inside the function, so it's horizontal. It's a horizontal transformation. It's a divide to, so it's going to be a stretch. Now, divide to, you might think it actually go, towards, squeeze it. But no, remember horizontal transformation is always working the opposite way you think it would. So it's actually a stretch of twice bigger, right? That means if you have that, the period, now it's going to be 4 pi. Now I'm going to go ahead and sketch the cosine. So it would look a little bit wider than it should. So that all the way back. Now, since we know it was a horizontal stretch by a scale factor of 2, it is twice as wide, so the period now is actually 4 pi. But then they ask for the range from 0 to 6 pi, meaning you have to draw an extra half a period. So just so you know, that is 2 pi, right? Right in the middle would have to be 2 pi. So you have to draw it all the way back down to the bottom, and that is my 6 pi, right? That's my 6 pi here. Yeah, so that would be the full range that you're considering. Then you're looking for the fact that this graph is over root 2 over 2. You do not need to know the actual value of root 2 over 2. You just need to know that it's going to be somewhere between 0 and 1, okay? Because then, assume like that's root 2 over 2. Actually, you should know, right? Like root 2 over 2, that's something about like 0.7. You just have to know that it's going to be between 0 and 1. Because like, okay, the 0, right? That's 1. Because it doesn't matter. Like it will cut the same amount of points, right? So let me go ahead and now draw this line. All right. It's hard to draw a straight line. Okay, fine. That's good enough. Right. And then what they want is for the cosine to be bigger, means taller than that part, which means you're looking for this region and that region. And that's it. That's actually it. That's the only two regions that you need to think about, right? So that means we have to find these intersection points, right? These intersection points. Then to find it, you already know because we already get this, yeah? So we know that, then we can actually, how about we go ahead and solve it, right? So consider cosine x over 2 equal root 2 over 2, right? Then you can actually solve it. That means x over 2 would therefore be pi over 4, right? That would be one of the solution. You know there are two more that you need to look for, right? And that one here you have to do your ASTC, meaning you have to do your ASTC, and then that is the first one, right? Pi over 4. That pi over 4 is the first solution. And just so you know, I mean, I'm looking at the positive ones, right? So the next one is going to be this one here. And this angle is also given by pi over 4, but we always come from the positive x-axis, so it goes all the way, giving this just 2 pi, well that's 2 pi, 0 over 2 pi, right, minus pi over 4, which is something like 7 pi over 4, right? That would be the solution of this one. That means the next one is 7 pi over 4. But we are not done because since we have sketched it already, we already know that there should be one more that we're looking for, which is the one that goes around a circle. Let me just use another color for this one, which is the one that you start from here, you go all the way around and back to itself. That one is your next one. So the next one after here is pi plus pi over 4 and adding one period to it, which is adding 2 pi, right? Which means that would be equal to 9 pi over 4. So the next one is 9 pi over 4. Okay, and therefore you would get your x equals to times 2 to both sides, pi by 2, 7 pi by 2, and 9 pi by 2. Meaning, now that you actually get all the values here, this is pi by 2, that is 7 pi by 2, and that's 9 pi by 2. Then you can look at all the regions and you will get it, right? So the first region would be x has to be between 0 and pi by 2. Now, whether to use equal or not, you have to think about it, right? When x is actually equal to 0, is still bigger than pi over 2. And can we have x actually equal to 0? Yes, because this is an inclusive sign, right? That means this have to include 0, because x could actually be 0, right? But when x is pi over 2, it will exactly be the thing. And this you have to look at this one here. Because we are looking at the function, the range for the function to be bigger than the line, right? Meaning it couldn't be exactly pi over 2, right? Therefore, it does not include pi over 2, because when x is actually pi over 2, it will be equal to the thing. It will be exactly equal to that line here. So you can't have that because you want the bigger than, right? The reason why for the 0 you have this part is only because the fact that, well, yes, at 0, cosine x is 1, right? So it's bigger than it, and also the range allows us to have a 0, so which is okay, right? And then the next range would therefore be the next one there, which is x has to be between. Again, it's exclusive because when it's exactly the same as those two angle, x is exactly equal to the line, but we can't have the equal. So that would be your 2 solution. All right, question 7. Let x and y be normally distributed with the following distribution, right? Now we know we are dealing with normal distribution. So first thing first, a little bit of recap. For normal distribution, they all look like a bell-shaped curve, right? Something like this. And what determines the shape, all right, is the fact that this a here, the standard deviation, would determine how wide the shape, the curve is. The bigger a is, the wider the curve, all right? That is determined by the standard deviation, which is a here. And this 14 here, the mean, which is the mu, what tells you where is this graph, like where the middle of the graph is, right? Because it should be completely symmetrical, and the mu, the mean, what tells you where is the middle line, okay? So this is what this 2 parameter does. Then if you think about it, okay, look, now you have x and y, right? So of course it's best to sketch it out, right? So let me sketch x first. I mean, we can first sketch them separately, and then of course afterwards we'll probably have to sketch them on the same graph. But okay, let's go for x first, all right? Yeah, let's go for x first. So okay, so that's x. And then since we know that the mean is 14, that is 14, and this is the y, like the width of the thing would be the same with y because they have the same standard deviation, right? And that would be my x distribution, and then I'll draw y on the side, all right? You know, I really should draw them on the same graph just to save some time, but just for, you know, for better understanding, I'll draw them separately first, all right? Now that would be y, and we know that the middle line this time will be 22 because the mean is 22. All right, now both graph, even though my drawing is rather bad, but you have to know both graphs should have the same shape, meaning because like they have the same standard deviation, right? Both of the standard deviation is a, right? If the standard deviation is the same, that means the width of the graph should be the same, meaning both graphs should look exactly the same, except the green one, y, is a little bit shifted further out, meaning it's just really a translation of x to the right, yeah? And they should have exactly the same shape, all right? Now, okay, part A, they were saying, okay, find B so that probability that x is bigger than b is equal to the probability that y is smaller than b. Now, what does that mean, right? Now, on x graph, let's say b is like somewhere here. It doesn't really matter because I just want to illustrate the point, right? And then what does it mean by the probability that x is bigger than b? right? Now, is 14 in that, if b is there, of course 14 is smaller than b, so it doesn't count, right? So you're looking for the fact that, well, that is x, right? The fact that x is bigger than b, so you're actually looking for all of these area here, right? That would be the probability that x is bigger than b, right? Now, using a similar idea, let's say now b is somewhere here, okay? Then you're looking for the probability that y, of course, is the y, is smaller than b, is of course all the region before it, right? And that would be probability that y is smaller than b. Now, you want both of them to be the same. What could you do? Now, it might not look that apparent for now, but what we could do is actually we can sketch both of the graph on the same axis. Then it will be a little bit more apparent. So if I were to sketch both on the same axis, so it will look something like this. So that means we have to draw a little bit longer here. And let me use, again, blue for x. So it will look something like this. And that would be 14. And the green one should really overlap with the blue one. Let's start somewhere here. And then it will be somewhere here because, yeah. And that would be 22. Now, what you're looking for, do you guys realize that you are actually looking for the fact that this part here, so that this region here, let me use blue actually, so that this region here equals to that region there. And that would, of course, be our b, right? Only in this case will we have the area of the green side equal to the area of the blue side, right? I mean, this is really a symmetry argument, really, right? Then in that case, the b could only be the midpoint between these two numbers, right? So you can basically argue that b has to be the midpoint of 14 and 22. And of course, therefore, b is 14 plus 22 divided by 2, which is going to give you 18. So then b is 18. But of course, if you cannot spot this, if you cannot draw a graph, what else could you have done? You can go from a purely mathematical argument, meaning you do not draw anything. You simply notice that, okay, look, if that blue region and the green region have to be the same, that means if I turn it into a z-score, right? Now imagine that is if I turn it into a z-score, right? And that would be z. Let's say that's z, right? In that case, that b here, the b, let me screen, the b for y has to be minus z. If not, they would not have the same area, right? If I turn into z-score, that means everything is standardized. Then the graph is located at exactly at the same place and blah blah blah. Then in that case, I can still draw a graph actually. Then in that case, both x and y would look exactly the same. Let me just draw it here. In that case, both x and y will look exactly the same in the middle like that. Because if I turn into a z-score, both of these lines are standardized, right? Both these lines are standardized, right? If they're both standardized, what you're really looking is you want this part b. Well, that would be the z, right? It would be the z version of the b, right? Would have to be the same as the minus z on this part, right? That region, since they're symmetrical, right? That region has to be the same as that region for that to work. So then you can go through a completely mathematical argument, basically equating the two z-score. Meaning you can do something like, actually, I'll just do it here. You can do something like the z-score of x for b, right? Which is a b minus 14 over the standard deviation, which is a, has to be equal to minus, because of minus z, right, of b minus 22 over a as well. Then of course a little bit of calculation, you would get 2b equals to 36. So of course a b is 18 as well, for sure, because you should only get the same answer. All right, so that's how you do it. I would say this is a rather hard question, a bit tricky actually for a 2-marker. But okay, let's see for part B. Now part B, okay, so they're saying, okay, it's given that the probability that x is bigger than 20. Now of course, for these type of things, it's always the best to really draw it out, right? Let me just scroll down a little bit. Okay, let me just draw a line here so that for below we are doing part B. All right. So of course it's best to draw it out. I'm gonna do x, right? So let's do that, and then of course I'm just gonna draw the same thing. Now of course in the exam you really do not have to do this. It's just for explanation wise for now. Okay, so of course this here is still 14, yeah. And look, they want p, the probability of x is bigger than 20. Now 20 is somewhere here, right? That's 20. So that means this is the probability, right? That probability here is 0.112, right? And then now that's x, and that's x. Okay, this is like this is the x distribution. Now they ask for the probability that y. They ask for the probability that y is between 16 and 28. So of course, for sure, we're gonna have to draw y as well. All right, we're gonna draw y as well. So we're gonna draw y, and y again. This is 22, and we are looking for between 16 and 28. So we're looking for this region here. Okay, right here, right here. Look, I don't know if you can see it, but it really to do with how good is your number sense, because like by now you should have guessed, right? Like, look, there's no way you could have done it if not the fact that this blue region is probably going to be exactly this part that's missing out, right? Well, then of course we're gonna check, right? But like this is the instinct or the gut feeling that you should have, right? Let me just scroll down a little bit more. I mean this blue region, right? Well, then we gotta check, right? Since we know that x and y, remember they have the same standard deviation, meaning they should be the same width. Then we can really see, right? Between here to here, this is a 6. And of course, you can see from 22 to 28, this is also a 6. That means, actually, I can also draw that here, right? The region that you're looking for is exactly this region in the middle, right? So, of course, you can go for a graphical argument, and then you can simply say, okay, therefore, you can say since, well, a little bit of logic statement, right? Since x and y has the same shape, but y is just a translation, right? Y is just a translation of x. We can see that, and then you can argue like the graph statement. We can see that that is the same. Therefore, the probability that y is between 16 and 28 is really just 1, which is like the whole area. Take away 2 of this blue part. 2 times 0.112. All right, which is like that thing, right? Therefore, the answer should be 0.776. Then you're done, right? Then of course you can also go through a mathematical treatment, but for this one I really don't think you need to, because since you're not given a calculator, if you see a normal distribution question, most likely you are going to have to spot for this kind of symmetry between the graphs, or basically how the area relate to each other. However, if it's in a paper 2 question, then probably you have to get your calculator out and start doing your inverse normal distribution, or you're going to do your normal CDF and this and that, okay? All right, question 8. So a small cuboid box, and I have a box here, with, you know, your length, base, width, all of these stuff they're given. Of course, x and y is bigger than 0. Now they say the sum of length, width, and height is 12, and part A is very straightforward. Write down the expression of y in terms of x, right? So simply, you know that if you add them all up, it's 12, right? So you can just write 3x plus y equals to 12. Therefore, y equals to 12 minus 4x. Then you're done. Now, part B, they tell you that the volume is v. Find the expression of v in terms of x. That's, again, very easy. V would therefore equals to, 3x multiplied by x multiplied by y. And of course, then you're going to substitute the thing. You get 3x squared multiplied by 12 minus 4x. So you get 36x squared minus 12x cubed. Then you are done. All right. Now part C, find dv dx. So let's go. dv dx is just differentiation. You're differentiating polynomials, so very easy. The power drops down, and then the power decreased by 1, and that'd be 36x squared, and then you're done, right? So far it's so easy, like all of them are very straightforward. Part D, I, okay? So find the value of x for which v is maximum. Now, do not rush in to do this first. I want you to understand what does it mean, right? Why is it justified to ask such a question? Like, what is the value of x for which v is maximum? What does it really mean, right? So the idea behind this question is this, okay? So you actually have a condition that the length, the width, and the height has to add up to 12. Meaning you actually have a limited amount of distance or limited amount of length you can distribute between the length, width, and height. For example, if your length and width is really big, your height would be really small. Then you think about it, right? Imagine you have your x, right? Find the value of x, right? If you want a bigger x, right? If you want a bigger x here, that means your width, let's call that length, right? Then the length will have to be longer, and of course the width is longer. But remember, we only have a maximum of 12 cm to distribute between these 3 dimensions. That means the y would have to be smaller, right? So what they're really asking is, imagine if x keeps changing. So which combination of width, length, and height would give you the maximum volume? It's like the idea between, okay, if x is really big, right, then you have a really, really big base, right? You have a really, really big base of a cuboid, but because the total distance, the total length that you can distribute is 12, that means you're going to sacrifice a little bit of height, right? That means you're going to have a rather short cuboid, right? And yeah, so you're basically having a bigger base by sacrificing the height. Or you can make x smaller, you have a smaller base, but since now that you have more length to spare, your cuboid could look longer, taller, higher, well, taller, right? Taller, yeah. Yeah, so this is the essence of the question, right? Is to ask whether should you, for example, sacrifice the height for a bigger base, or should you sacrifice the smaller base to get a taller cuboid? Which type of combination of x's, x and y's, right, of course, will give you a maximum amount of volume. This is the idea, the essence behind why can you do such question, right? This also works for, in general, all of these, differentiation question, like pretty much all the time, right? Maybe you have, for example, a cylinder. Let me use a different color, right? Maybe you have something like a cylinder, and then, okay, look, they would give you, the surface area of the cylinder is fixed, right? Then you'll be wondering, okay, how to maximize the volume, right? Should you, for example, make the cylinder really wide but then really short, or should you make the cylinder really like narrow but really tall, right? Which one is going to maximize the volume, given that some of them is fixed? For example, surface area is fixed, right? This kind of thing. And then in this case is the dimension which is fixed, and which combination could give you the biggest volume, right? So that's the idea behind this question. Well, then of course the math is a lot easier actually. The math, you simply have to just differentiate it, which you already have done, right? And equate that to 0. Now, the brief idea behind why you can do this, just a very quick recap, is if you have any function, all right, that's y, that's x. If you have any function fx, and if you differentiate it, you're going to get the gradients of the function, right? And the fact that for each of the maximums and minimums, you will always have a flat line, meaning for both of these, the gradient, well, y equals mx plus c, so you're m, right? The gradient will have to be 0 because they're all flat lines. So the idea is that if you differentiate it and equate it to 0, that means it's going to be either a maximum or a minimum, or else the gradient will not be 0, right? So of course then we go ahead and do it. So 72x minus 36x squared equals to 0. Now the way to do this question, a lot of people will go straight ahead and cancel an x, right? Divide x. But the more rigorous way of doing this, you have to go for this, right? You have to factorize into x, and then 72 minus 36x equals 0. And then x equals 0. Please don't forget this solution. A lot of people simply say, okay, I'm just going to divide x on both sides. But remember, x could also be 0, right? It's the idea behind, if this thing times this thing is 0, then either one is 0, right? So x is 0, or of course this bracket thing here is 0. Then of course this is going to give you a solution of x equals to 2. Then of course after all you're going to have to reject the fact that x is 0, because if x is 0 it doesn't make sense, because this couldn't be 0, right? It can't be 0. Yeah, it cannot be 0, so x has to be 2. So then you can say okay, so the value of x for which v is max is 2. Now, to justify your answer, it depends on how your school teaches you. The way I do it is I always differentiate it again. Because just now I already mentioned, right? If the gradient is 0, it could be a maximum point, but at the same time, it could also be a minimum point. So you have to justify, okay, would that actually, when x is 2, would that be a maximum, or would that actually be a minimum? So the way to check, you can do some, checking signs or whatever, but the way I do it, I just differentiate again. I do the second derivative test. Let me zoom out a little bit. All right, so right, I would justify by just differentiate it again. So d squared v dx squared would therefore equal to 72 minus 72x. And then after I do this, I will substitute the fact that x is 2 and check what the value is. So the notation that I would do is I would do this and then align when x equals to 2. That means evaluating the differential when x is equals to 2. That would of course be 72 minus 72 times 2. That would be minus 72, right? Which is a negative, right? Now here's the thing: the second derivative test have stated that if your second differential evaluate to be a negative number, then it will be a maximum. All right. So if it's negative, it will be a max. If it's positive, it will be a minimum. And one more thing: if it's 0, okay, if it's 0, actually it's called a point of inflection. I'll just write inflection. Okay, we forget about this for now. In this case, just vary this maximum minimum. In that case, yes, we found that, so we know it's a maximum, so we have justified it, right? We justified it because the second differential evaluate to be negative, right? And part E, I don't have enough space, so I'm going to do it here. Find the maximum volume. Then that's straightforward, right? So now that we know V is max when x equals 2, so we simply do V2, right? Like evaluate the volume when x is 2. Then we know volume just now here, we got that, right, from part B. So you're going to be 36 and then 2 squared minus 12 and then 2 cubed. That would give you 36 times 4 minus 12 times 8. And I'll skip the calculation, then I'll just give it 48. Of course, cm cubed, for the unit. And that will be it. All right, question 9 is going to be a 3D vector question. Now, for 3D vector, it's a little bit tricky because it's not that easy to sketch. Now, if it's a 2D vector, well, you don't even, just go straight away, you sketch the thing straight away because 2D vector is so easy. But 3D vector, it's a little bit hard to do because it's in 3D, right? But regardless, we can still try because sketching it out is going to help you like a lot, right? But even if you cannot, right, you can still do part A because they are just asking for the dot product. Now, if you do not know how to find a dot product, then there's nothing I can do, right? So let's go for part A, all right? So let's go for part A. Let me just do it here, actually. So let's do OA, okay? OA dotted with OC, all right? I'm just going to save some space. I'll do it here. That would be, OA is going to be exactly that. These are position vectors. So that dot with OC, which is minus 1, K0. Well, okay, then that is really just that times that plus that times that plus that times that, right? So minus 2 times minus, okay, let's actually write it down, all right? Like, okay, fine. Plus 4K plus minus 4 times 0, which is equals to, well, basically 2 plus 4K, right? And then the other one, let me do it, OB dotted with OC is going to be, again, OB is simply that dotted with OC, which is again minus 1K0, which would equal to, well, minus 6 plus 8K, right? then you're done. Okay. Let me just use red to put this to answer down so it's a little bit clearer. Okay. All right. Now part B. I'm gonna do part B here. Let's do part B here. So given that AOC equals to BOC, now here's the thing, right? You can go for a completely mathematical route, which requires no drawing. But if you somehow manage to draw something out, even though it might not be accurate, it would regardless help you a little bit. All right, it will help you a little bit how to understand the question, because it might not be obvious to you. What should you do straight away? Because, okay, look, I know these two are the same, so what can we do? Now, you should have an instinct that, okay, look, if we're doing angles, and look, they gave you a hint of doing dot product, surely we're going to use the cosine law, right? The vector version of the cosine law. Yeah, so this is the thing where if you know this straight away, you probably don't even have to sketch the diagram. You can probably just do it mathematically. But in our case, let's actually sketch it out and see what it looks like. So let's say we have the origin here, okay? That will be the origin. And then you have ABC. Now, we try our best to sketch ABC, okay? A is -2, 4, and -4. So if you really want to be very rigorous, sure, you can actually sketch all of the axes. If you're interested, the axis looks something like this. And the vertical is always the Z axis. Now, X and Y is really just convention. It depends. It really depends, right? Some people do X and Y like this. Some people do X and Y the other way. The way I do it, actually, I would do X here and Y there. But it really doesn't matter, okay? So for A, okay, it will be -2. Actually, let's draw the -1 as well. It goes here, right? So -2, 4, and 4. So -2 should be somewhere here, 4, and -4. So it should be somewhere like down there. So that is my A. Yes, and then B is 6, 8, and 0. So 6 is here. This is 6, and then 8 also a positive number, and 0. So it should be on the plane, which is somewhere here. And C, we do not know where it is, but I mean it's really up to you. You can draw it anywhere you want, really. But for now, we can actually get a triangle here. That is B, right? And you have this line here. That line goes to the bottom. And let's say C is somewhere here. I don't know. It doesn't matter. Then that's C, right? So they're saying that AOC, meaning if you get that angle here, that's AOC, right? AOC. Let me use another color actually. A is the one that goes down there, and therefore that would be AOC, right? And then BOC would be the green angle that goes, let's say that's B, then BOC would be that angle there. Okay, now I'm not that good at drawing 3D, but I hope you see what's going on. But regardless, then you can see you should be considering the two angles. And remember, when you're dealing with vectors, especially they hinted by asking you to do the dot product and then they look for angles, surely we are doing cosines. We are doing the cosine law. Meaning we'll be doing with this cosine law. Meaning you will do the cosine theta equals to u dot v, the two vector dotting together, and then over the mod u and mod v. You're going to be doing this one. Of course, it could look, I mean, this could look different, like you can move this over, but this is the thing that you'll be dealing with. Now, of course, you know the two angles are the same. Surely the cosine of them has to be the same as well. Therefore, what you can see straight away is then you can see, okay, the two vectors. Let's do the red one first. The red one, can you see the red angle here? The AOC. AOC, think about the AOC. Then you can first, let me do it here actually. So you have cosine of AOC here would give you, since AO and OC, you can see AO, this is the AO, and OC here is the two lines that make up that angle, right? Therefore, they will be the two vectors that you'll be dotting. So you will do OA dot with OC over the mod of OA, and of course the length of OC as well. So that will be that. And then the other equation you can do, of course, the green one is going to be OB, which this, and OC as well. That means your cosine of BOC is going to look something very similar, which is OB dotted with OC, because they are the two lines that make up the angle, right? Over, of course, the mod of OB and the length of OC. There we go. So that would be how you do it, and then you give it a guess. You equate the two, right? So then you would equate the two, and then let me use the red for red. How about this? Now we already know OA.OC is actually 2 plus 4k, right? From the first thing. So you get 2 plus 4k over the length of OA times the length of OC, right? Like that would equal to, hold on, let me use a different color, and I'll use green, right? OB.OC, you already got it, right? Now, there's a practice I always do is I know it's minus 6 plus 8k, but I always start with the positive. It looks a little bit easier. I mean, it looks better to me because I don't like to deal with negative numbers. And of course, that would be OB, the length of OB, and then the length of OC. Right. So there you go. And then of course, you can both cancel this out. You can times, because the length of OC is just the length of OC, right? So then you can finally do your work, which is 2 plus 4k multiplied by the length of OB in this case. And then we'll figure out the length is later. That's just Pythagoras, really. 8k minus 6, and then the length of OA. Hold on. The length of OA here. Then you can basically get the length of it. Let me zoom out a little bit. So length of OB, right? So OB was 680. If you see 6 and 8, surely you know that's going to be 10, right? Because that's a Pythagorean triple. But we'll still do it just for the sake of it. So 2 plus 4k multiplied by the square root of 6 squared plus 8 squared plus 0 squared. Yeah, by now you have to know that's a nice Pythagorean triple, right? Would equal to 8k minus 6, and the length of OA is going to be again square root of minus 2 squared plus 4 squared plus minus 4 squared, right? And therefore you will get 2 plus 4k multiplied by 10 equals 8k minus 6 times 6, because that actually adds up to 36. Then of course you do it 20 plus 40k equals to 48k minus 36. A bit of rearrangement. 8k here will be 56, so k is going to be 7. Well, which is indeed what they want us to show right here. Right, so that will be a nice 8 marker. Not that hard, but yeah, you gotta have a think about it. Now part C. Calculate the area of the triangle AOC. Now, I think that's very straightforward already. There's a formula that you need to know, which is a half AB sine C, right? You have to know that. So let me zoom out a little bit. All right, I'm gonna try to draw the triangle somewhere here. Okay, so I'm gonna do part C here. I'm trying to draw AOC, right? So how about I actually draw the triangle AOC and see what it looks like. All right, that's A. That was O, and that was C, right? So now that we know K is 7, what we can do is actually, well, we already know OA. We found OA, right? OA was actually 6. And you can find OC, now that you know K is 7, because now that means C is going to be minus 1, 7, and 0. So that means OC, the length of OC, is going to be square root minus 1 squared plus 7 squared plus 0 squared. I'm not going to write it. So that's going to be square root of 50. Simplify it. It's going to be 5 root 2. Okay? That means this line is 5 root 2. Then you have to know by now that the area of this triangle could just be given by, if you know this angle, right? If that's theta, that will be half AB sine theta, right? Well, half these two lines and times the sine theta. But then to find theta, again, very straightforward because you just do the dot product of it. Let me just, hold on. Okay, that's part B. Let me continue here. So to find angle theta, you can do cos theta would equal to, of course, OA dot OC, which again we already found, divided by the mod of OA and mod of OC, which is OA.OC, we got it already. That's 2 plus 4k. Now that we know k is 7, that's 2 plus 4 times 7, which is 30. Okay. Out of OA, we got it. OA was 6, and then OC was that, so that's going to be 30 root 2. So that's going to be 1 over root 2. Right, then I hope that is strikingly alarming for you, because that means theta is 45 degree. Okay, that is the special angles you have to know. Another way to write this, by the way, is root 2 over 2. Maybe that helped. All right, that's the same thing. So I hope you can see that theta is 45 degree. That means, do I have enough space? Yes, I do. So that means the area, okay, by now you have to know that, half AB sine theta. You have 6, 5 root 2 sine of 45 degree, which is also root 2 over 2. And then therefore, do a little bit of math that would give you a nice 15, right? And then since they didn't give you cm, so just unit squared. Okay? All right, question 10, which is the last question. So it's supposed to be the hardest, but we'll see. It's also a 14 marker, so we'll see. So, okay, so you're given a function gx, which is an exponential function, all right? Because xp, well, p and q are both real, and p is bigger than 1, right? So it's going to be an exponential function. And then they tell you that the point A lies on the graph G, all right? And they also tell you there's a function f, which is the inverse of G, all right? And point B lies on the inverse of the function, which is the reflection of point A along the line of y equals to x. Now, the first part of the question, well, part A is really easy, all right? They ask for the coordinate of B. Now, without even thinking, you will know that's going to be A and 0. Because, well, different way to think about it, right? So, first thing first, if you know it's going to be a reflection along the line of y equals to x, that simply means that you flip the x and y, right? So if point A was 0 and A, and it flipped, then we go to A and 0, right? That's what it means, right? But if you were to try to understand it through a function argument, now remember when you learn about function as a machine, right? So for example, if you have a function g, you put the x value, that's your input, right? You put your input x, and then you get your output y, right? That's your output. Or domain and range, right? In that case, the fact that, the point A, 0, A, lies on the function of g, lies on the graph of g, that means you put 0, it gives you a, right? That's what it means, right? It put you 0, it gives you a. That's why it lies on g, right? That means now if you imagine you have an inverse, the inverse is f, right? Which is g, well, the inverse is f, right? It's g minus 1. That means inverse simply means if you have a function and the inverse of the function, it simply means that now instead of the output, you are putting the output in and you will get the input back. You flipped input and output, right? That's what it meant. That means this time we will be looking at the fact that you put A in, it gives you 0 back. Therefore, now your new x, your now input, that's your x right now, and that's your y, right? Because now that is my input, because the inverse is that it flipped, right? And now this is my output, right? Now the fact that this time, if it's an inverse, you put A in, you get 0 out. Therefore, you would just get A with 0, because that is the equivalent point of point A on the inverse. Then that means it has to do the other way around. Now, of course, another way to do it is to sketch it. And for this type of question, it's really, really useful to sketch it, because, when you look at the question like below, part B, part C, you're going to be dealing with a bunch of tangents and a bunch of normals. It really is the best to actually sketch the graph, or else it's going to be quite hard to think about it in your head. But normally this graph is quite hard to sketch, but actually this is only an exponential, so it should be quite easy actually. So let me sketch the graph here. I'm going to sketch it a little bit bigger. So let's put down the axis. Now that we know that the function g, the original function, g is an exponential, because it's just p to the power of x, right? That means it would look something like this. Well, the fact that I draw it a little bit higher than it should be is because it plus q, right? That means it's a vertical translation. It's shifted up a little bit, right? And that means, actually, let me use a different color. Let me use blue for this one. So that would be my function g, okay? That's function g. And that point right there, actually the y-intercept is my a, right? Okay, and then let me draw the line that you got to reflect on. The line x equals to y would be something like this. That's a straight line that you reflect your graph upon. Would give you the line, let me use red for this one actually, something like this, all right? I mean, if you tilt your head, you see that's the reflection, right? That's the mirror. The middle one is the mirror. And of course, that is the corresponding point of A, which is our B, right? And in that perspective, you should also see that if that was A, that's B, you would just flip the X and Y coordinate, because back then, this number here should be an A, right? That means in here, now this would be A here, right? The point here, that would be A. And that would be B. Of course, I can write A0 like that, right? Okay, so now we go to part B now. We are set. We have drawn all the diagrams, and then we'll now see what part B is. So they say that the line L1 is the tangent to the graph F at B. Now, this is my function F, right? This is my function F. So they are saying that that's a tangent. L1 is a tangent at B. So to draw a tangent, you should know how to draw it, right? So that means this line right here, this straight line here is my tangent, right? This line is L1, right? That is L1 because that is the tangent at point B, right? So yeah, so that is L1. Now they are given that f prime a, f dash a, differentiating the function give you blah blah blah. Find the equation of L1 in terms of x, p, and q. Now, since we know that L1 is going to be a straight line, so of course we can, straight away do y equals to mx plus c, right? Let's call it m1, right? m1 x plus c, right? We know it's going to be that form because it's a straight line, right? That means we've got to find the gradient and we've got to find the y-intercept. Now, the gradient should be relatively simple because they actually gave you that already. By now, you have to know that if you differentiate a function, that gives you the gradient at that point. They even give you the fact that, f dash a, meaning after you differentiate the function f, you put the number a as your x. That is exactly the gradient. So we know this is basically straight away this 1 over log p. So we're already halfway done, right? We just got to find c. Now, how do we find c? I mean, this is sort of standard procedure already. If you have the gradient of a line, and you just need a point to find the thing, right? So then you look for the point. We also know that it goes through, point B, right? So we already know that we can substitute the x value and the y value for B into the equation and to find C. However, just one very minor thing is the fact that they ask you to give the L1 in terms of x, p, and q, not in terms of A. That means we need to find a way to express A in terms of p and q. Now, very luckily, we already have that on here. Because we know that the original function actually goes through the point A, right? So from that, we can actually figure out what A is. So what we can do is, we know that the original function gx goes through A, meaning, well, actually, from this function notation, we already said it, right? If you put 0 in there, so g0 would just be A. That's what it meant by the point A lying on the graph. So then you would just get p to the power of 0 plus q equals to A. And p to the power of 0 is just 1, right? So 1 plus q equals to A. So we know that A is 1 plus q. That means now the point B, we could write point B as 1 plus q and 0, right? And then, therefore, we can substitute this in here, and of course substitute the x into here. Then we can find out C, right? So let me do it in the middle of, like, say here, right? So that means L1 now, we can do y, which is 0, right? So 0 would equal to the gradient, we already know, which is 1 over log p. X is 1 plus q plus c, right? Then a little bit of rearrangement, it should get c is simply minus 1 plus q over log p, right? And knowing all these, we will get our final equation L1 is simply y equals to 1 over log p x minus 1 plus q over log p. That would be the final solution to part B, because we have make L1 in terms of P, Q, and X, right? Now part C, we're given even more information. So they are saying that there's a line L2. Now L2 is the tangent to the graph of the original function g at A, right? That means this time we can draw another line. Now let me use yellow for this one, meaning this time I have the tangent at this that go through here, this tangent here. I am going to call that L2, right? That's L2. Yeah? And it also goes through the point -2, -2, meaning it goes through the point here. Let's say this called I mean, it doesn't matter, but like that go through this point, -2, -2. So that is the tangent here. Let me draw it brighter. There we go. And then it has an equation of that. All right? So I'm really running out of space here, but just know that L2 has an equation of that. All right? Okay, and then they also tells you that the gradient of the normal, okay, the gradient of the normal at G to G at A is blah, blah, blah. That means, of course, we got to sketch the normal, right? Now, I'm really running out of color here, so I'm going to use a purple here, all right? So that means this line right here, that is the normal, isn't it? Let me just draw it a bit thicker because it's a very light color. That is the normal. And also it has to be a 90 degree, so that's a normal. This normal here would have a gradient of 1 over ln 1 over 3. That, okay, it would have a gradient of that. Then, okay, after all of this information, they ask us to find the equation of L1 in terms of x only. Now, remember just now in part B, we already got the equation of L1, right? But it is in terms of P, Q, and X. Now, the part C asks us to simply find the equation of L1 in terms of X, meaning we have to find what is P and what is Q, right? So then we can just write them as numbers. So let's start with P. Well, that's a very good reason why we need to find P first. That's because they very nicely, they gave us the gradient of the normal. And we already know that if we have the gradient of the normal, surely we can find the gradient of the tangent as well. Now that's the gradient of the tangent, right? Because their product is just -1 as they are perpendicular. Therefore, what we could write, by the way, L2, actually now we have space we can write here, right? L2 would have a gradient of log P, right? That we know from here. So then we know that log P multiply by, let me use the purple here, right? 1 over log 1 over 3, that will have to be, let me just black, -1, right? That's the thing with perpendicular lines, right? If they're perpendicular, the slope will multiply to -1. So we can finally do the math, a little bit of math here, so you could get log P is basically just minus log 1/3. Then by now, you would know that the negative could go there as a power. So it's going to be log P equals to log of 1/3 to the power of -1, which is the reciprocal. So it's going to give you log P equals to log 3. Then very obviously, P is 3. Then we are done. So we already got P. So we are halfway there, right? Now we need to find Q. Now to find Q, what could we do? Well, of course, we're going to use the piece of information that we still haven't used, which is the fact that the graph passed through -2, -2, right? We have not used that. So we know that the, let me use the yellow, right? So we know that the equation of L2 is given in the form of y equals to log P. Well, we know P is 3, so log 3, and then x plus Q plus 1. And we also know that the graph goes through the point -2, -2. That means we can substitute the x and y value into the x and y value to solve for Q, right? So then, of course, I'll get -2 equals to log 3 of -2 plus Q plus 1. Then a little bit of rearranging, you should get Q simply being 2 log 3 minus 3. Then basically we are really done, right? Because we have got our Q here and also our P here, right? Then we simply need to put it back into the L1 equation and then we'll get our final answer. So let me scroll down a little bit. So finally, we can put this back in here. Let's go back in here. We will have a final equation. L1 is therefore y equals to 1 over log p. So we know p is 3, so 1 over log 3 x minus 1 over q. 1 plus q, so we actually know what q is that, right? So we can do 2 log 3 minus 2, because you're plus 1, right? Over log 3. And that would be our final solution. Okay, so after all, this is a rather long question, but of course that's the last one, right? You do not have to do that many steps. Actually, no, you do have to do that many steps. It's just that I try to explain it more clearly, so I draw the graph and this and that. But if you know how to find tangent and normal, and also by now, those have to be very systematic. Though you have to know them already. It's very, always is this, right? You do the, define the gradients, you have a point, and you get a normal, you get a tangent. Then after all, this is not that bad of a question.